Okay, so let's go back to our general equation for the slope of what we found out is the secant line. This is our slope between 2 points, x2 and x1. And we said that x2 is really close to x1. And of course what we're trying to do is we're trying to get x2 infinitely close to x1, or infinitesimally apart from x1, so that they're almost indistinguishable. And what I want to do is I want to change our terminology up just a bit so it makes it a little bit easier to set this up. So here we have a graph, and of course in this graph we have 2 points, x1 and x2. And they're really close. They're separated by some tiny little difference, delta x. And what I want to do is I want to redefine that second point. If this is x1, the second point is actually x1 plus a tiny little bit. So instead of calling it x2, I'm going to call it x1 plus that tiny little bit. And what that does to our function, if our function initially was f of some second point minus f of some first point over x2 minus x1, if I'm recalling x2 x1 plus a little bit, then I'm going to rename it like this. F of x1 plus a little bit, that's the value at this second point, minus f at x1. And again, down here I need to rename x2 as well. I'm going to call that x1 plus a tiny little bit minus x1. When I do that, you notice that the denominator simply becomes, well, x1 plus delta x minus x1. The x1's cancel, so this function just becomes f of x1 plus delta x minus f of x1, all over delta x. Keep this equation in mind for the next video. This is going to be very important.